Hey, it's Mr. E here, and in this video I'm going to show you how we could find the measurement of arcs intercepted by parallel lines. So let's begin with this definition of an arc. An arc is a portion of the circumference of a circle, and it can be measured in degrees relative to the central angle. So let me give you an example of what I mean by an arc. So it's a portion of the circumference of the circle. So this highlighted portion of the circumference, remember circumference is all this around the circle, and an arc is just a portion of that circumference. So we can call this arc AB, and arc AB would measure, we could say arc AB measures 90 degrees because the angle, the central angle that's intercepting the arc is 90 degrees. And this is a central angle because we're going to go ahead and assume that this vertex here, let's call it vertex O, is the center of the circle. So I could write that the measure of arc AB is 90 degrees, right? You can also think about it this way. The whole circle is 360 degrees, and a quarter of the circle, or a quarter of that portion of the circumference, should be 90 degrees, right? Because 90 degrees is a quarter of 360. All right, so that's what an arc is. Little brief summary on it. And let me give you a theorem that we're going to be using in this video. So there's a theorem that says in a circle, parallel chords intercept congruent arcs. And what do we mean by that? So let's suppose that segment AB is parallel to segment CD. So these two lines are parallel. The theorem essentially says that if you have parallel chords, which chords are these lines. A chord is just a line that connects 2 points on the circle. So it says parallel chords intercept congruent arcs. So these two lines are parallel to each other. Therefore, arc AC is congruent to arc BD. These two arcs measure the same because these two segments, or these two chords, are parallel to each other. All right, so here's our first example that we want to go over. It says in the diagram of circle O below, chords AB and CD are parallel, and BD is the diameter of the circle. What is the measure of arc BC? Well, we just learned that if you have parallel chords, that they intercept congruent arcs. So arc AD should be equal to arc BC. Therefore, arc BC must also be 60 degrees. Let's try another example. It says in the diagram of circle O below, chord CD is parallel to diameter AOB, and the measure of arc AC is equal to 40 degrees. So the way we read this notation here, that says the measure of arc AC equals 40 degrees. Okay, so let's label what we got so far. Well, we know that these two chords are parallel, or these two segments are parallel to each other. And we are also told that the measure of arc AC is 40 degrees. So that's 40 degrees. Then we know automatically that arc DB must also be 40 degrees. But the question is asking for the measurement of arc CD. So we want to find the measurement of that arc. So, I wonder how I could find that. Is there a clue in the question? There is. We are told that AOB is a diameter. Okay? Now, what you need to know about a diameter is that a diameter cuts right through the middle of the circle. So here's where I'm going with this. I want you to see that arc AC plus arc CD plus arc DB should be equal to 180 degrees. Now, why is that? Well, remember, the diameter is cutting the circle in half. And what that means is that this half over here is, of course, 180 degrees, and then the top half will also be 180 degrees. So that means that these three arcs added together, arc AC, arc CD, and arc DB, must be equal to 180 degrees. So if we know arc AC is 40, and we also know arc DB is 40, and the three of them add up to 180, we know that arc CD must be equal to 100 degrees, right? Because 40 plus 100 plus 40 equals 180. All right, that's it for this video. I hope that it helps. Take care.